And good afternoon, class. So we are done with conduction through composite walls. Let us go with the conduction through pipes. Mhm. Eto na. So, piping systems. Commonly, sir, sa bahay namin meron kaming mga tubo. Well, actually, yung mga pipes yan, once na nagkakaroon ka ng fluid transfer using your pipes, di ba? Sabi dito, yung pipes are the best means of transportation for your fluids of different characteristics, different viscosities, different temperature capacities, different densities, and different volumes, different flow speeds. Okay? Now, yung piping mo, when it came into contact with the fluid, if it is air, gas, or liquid, then we can say that heat transfer could happen. Why? It is based somewhat paano kung yung ambient temperature ng surrounding temperature dun sa pipe mo is very hot. So the piping system will have a heat transfer coming from the outside to the inside. O ngayon, yung piping mo naman, if that is steam pipeline, pag pumunta kayo ng mga steam power plant or power plant, meron silang mga tinatawag na service steam. Mga planta ng diesel power plant, meron talaga silang steam service kung saan yun yung nagko-condition ng oil. Anong ginagawa ng steam service na yun? It conditions the oil up to its recommended or optimal density and viscosity or temperature before operation. Iniinit nila yon kasi what happens with oil kapag nalalamigan siya, 'di ba parang natutulog, 'di ba? Nagiging gooey siya. Yung viscosity niya nag-iiba. Now, ganun po yung i-measure natin kapag mga piping systems. So, your pipes have thicknesses. Okay? And, going back to your conduction through plane walls, di ba? Yung iyong walls, kapag nag-pass through dyan, yung heat, anong ibig ko sabihin doon? Okay? When the heat passes through your walls, what happens to the heat? It is retained. It is constant. What does matter is the change in temperature. Okay? The change in temperature within the boundaries of the walls. Pagdating dito sa pipe, it is not the wall. We are always talking about the thickness of that pipe. Now, how can you measure the thickness of the pipe? Going back to your geometry. If you have here the cross-sectional area of the pipe, it is an annular section. Okay? From here up to here, this is the outer diameter of your pipe. From here up to here, this is the inner diameter of your pipe. Now, how will you get the thickness here? Okay, the thickness, kung gaano po kakapal yung outer boundaries ng pipe mo. So, in order for you to get the thickness, algebraically, DO plus DI, you add these two, that is equal to the twice ng thickness. Okay? DO, DI tuloy. DO plus DI. DO minus DI yan. Sorry. DO minus DI. Sir, ano po yung DI? That's instructor. No. That is the thickness. DO minus DI. Ay, hindi pala. Hindi ay pala tinatanong. Internal diameter, okay? Ayan yung kinukuha natin dyan. Now, in order for you to find the thickness, that is DO minus DI over 2T. Over 2. Now, let's talk about the pipe. This is your pipe, okay? Now, for the inner boundaries of your pipe, you will get the different radii. Okay? Different radii pala. Radii, hindi radies. Different radii. Where each radii, each radius, is the measure of the boundaries of the piping. Okay? Now, kung pag-uusapan natin yung composite walls and walls, as you can see, let me draw it first for you to visualize. Okay? I want you to understand this. Now, if you cut the pipe, sorry, if you cut the piping, if you have this cylinder, okay, this is your pipe, okay? Sorry sa drawing ko, ha? Huwag malikot ang utak. If you cut this pipe along the length, okay, para kang gumawa ng figure. Yes or no? Yes. Okay? You put up this figure when you cut the pipe. Okay? Yan. Kinut down mo yung pipe na yon from here up to here. Okay? Kinut down mo. Now, this will be the thickness. Okay? At some point, okay, that will be the thickness of the pipe. And this will be the measure of the outer boundaries. And that is the circumference. Circumference of what? That is the circumference of your outer boundaries. Well, that is given by the formula pi d. Yung circumference yan. Or simply, that is 2 pi r. Okay? Yan. Yan na tayo. Now, the assumption, let's go here, based on the figure of the heat flow is radially upward if the heat is, or the source of the heat is coming from the inside. Okay? The heat is coming out of the system. Now, the heat flow is radially upward. Ibig sabihin, papalabas ng system mo. What if the heat is coming out of the system, coming from the outside of the system, then it is going down radially. Okay? Ganun lang yun, the other way around. Now, following this differential equation will arrive with this formula where the total heat or the total heat transfer will be, hindi na natin diderive yan, ha? The total heat transfer through to composite walls, ha? Or through walls will be yung catex. Okay? Now, catex. Now, we are talking about pipes, di ba? We're not talking about composite walls. How can we translate it into composite walls? Sir, mahina ako magkabisado. Okay. Let us take note of this. Di ba sinabi ko dito that your pipe and the heat flow is coming inward. Okay? Coming inside. Okay? Coming inside, hindi pala inward. Coming inside of your piping. Now, it is transferred radially upward. Okay? It came out of the system. Now, ano ba yung trinabel niyang thickness? Okay? Let's talk about the thickness. Well, simply, yung difference between the two radii, pagpunta rito, yung naging change radially, okay, will be simply the lone of the ratio of the radii. Okay? This is now yung lone nung sa radii. Okay? The greater one divided by the lesser one. Okay? Ta-translate mo na eh. And then, your area. Okay? What is the area of a circle? The cross-sectional area of the circle. Okay. Paano natin kukunin yun? Paano ba natin kukunin? Sir, hindi ko alam. Hindi ko alam yung area ng circle. Well, actually, okay? 2 pi r. Okay? Hindi na natin to kukunin yung r dito. It will now become the length nung buong figure. This will become the length. Okay? Kapag pinroject mo, 'di ba, sa walls, ano ba yung nag-pass through ka diyan, saka nag-pass through? Binuyang-yang mo ito, kinat mo dito, ngayon yung heat mo will flow from here up to here, and then the thickness is yung ratio nung radii. Yan. Okay? Kung hindi nyo nagigets masyado, okay? Papaliwanag ko ulit. Yung rolyo, okay? Diba? Yung roll. This is the roll, yung pipe, nirolyo mo. Kinat mo sa gitna yung pipe, ibinuka mo, naging ano siya, flat figure. Okay? It does not mean na yung inside niya, kung if this is the inside, yan yung measure nung raday, yun dito, kalahati nito. Yung kalahati nito is the raday 1, yung malaking radius. Okay? Ay, hindi. Ito yung inner, outer. Yung outer is mas malaki parate. Pardon me. But does the thickness change? No, the length does not change. So, the cross-sectional area na magpapass through yung iyong entire heat will become simply the circumference. Okay? Where that is given by this one, 2 pi L. Okay? So, Q will now become, for pipes Q will become 2 pi of the length multiplied to, tignan nyo dito, ayan multiplied to delta T over the lone natural logarithm of the ratio of the greater radii to the lesser radii. Okay? And, syempre, wag mo kalimutan yung thermal coefficient or the thermal conductivity of the material that is used in constructing the pipe. Okay? To make matters very easy, okay, Q, okay, kunin mo na kagad to, K delta T. Cut. Okay? Now, I have here yung baba, the natural logarithm of those greater and lesser radii, and will now arrive with the circumference. 2 pi L. Very basic lang po. Kung hindi mo kayang magkabisado. Going back. Okay. We can also relate it with the general formula for the heat, which is yung Q is equal to delta T over the total resistance, where the total resistance is given by this formula. Okay? The total resistance is 1 over, di ba? 1 over, hindi po. Pag composite walls and then walls, that is X over K. Okay? Nirelate natin. Where nirelate nga natin itong Ln nung natural logarithm of the ratios of the radii to X. Okay? Di ba RT is simply RT. Take note, is X over K. Okay? Dito natin babasihan yan. Where RT now will become the natural logarithm of these two. Okay? And K will be simply yung kasama niya. Itong 2 pi KL. So, ito, translated now, kapag pipes, this will now become ln of R2 over R1 over 2 pi KL. This is the total resistance when you are talking about pipes. Okay? Ganun lang po yun sa pipes. How about, sir, kapag naging composite pipe yan? Hindi naman pwedeng bare pipe lang yan, okay? Hindi lang pwedeng, pipe lang siya, mainit siya. Hindi mo babalutan. Kapag di mo binalutan, magkakaroon ka ng heat loss. Kapag nagkaroon ka ng heat loss, mas mataas na energy ang i-exert mo the next time a fluid will pass through the pipe. So, let's get here. Okay. So, when we are talking about composite pipe, it is also the same with composite walls. For steady-state heat transfer, okay, the total heat that passes through those pipes will be the same heat throughout. Okay? Constant. Okay? And from the equation, the general equation delta T over the total resistance, okay, pwede nating hiwa-hiwalayin yung magiging heat transfer between them or the individual heat transfers. But we can say that those heat transfers from one pipe to the other pipe will be the same. Okay? Kahit magkaiba silang pipe. Okay? Magkaiba sila ng radii. it will always be the same kasi nga equal throughout. Ano pa nagbabago dyan? Yung temperature lang. Okay? Now, from here, inside, okay, you have inside, kukunin mo muna yung unang radii. Okay. And then, it will pass through, saan? Yung Q1 mo kasi hanggang dito lang yan. From 1 to 2. Q1 ang nandito. And then, from 2 to 3, at this point, up to this point, that is Q2. Okay. We denote yung Q1 natin in here. Then, ang pag-uusapan mo dyan, yung changes in temperature lang between points 1 and 2. Now, anong kukunin natin dyan? May dilemma ka dyan. Paano mo i-measure yung radii? Di ba pinag-usapan natin yung thickness? Actually, itong R2 is equal to R1 plus the thickness nung second pipe. And going here sa 3, sama na natin, yung R3 is simply yung radii nito plus T3. Ganun lang po yun. And thus, we want to generalize the equation from the inner side to the outer side. From point 1 simply, the total heat transfer is equal to the change in temperature at point 1 minus point 3. We assume that the hotter side or the hotter source is inside the body. Ln nung ratios of radii 2 over radii 1 divided by 2 pi K1. But we can say na ang length dyan is constant. Length is constant dito. Length is constant dito. The same lang. We can factor it out. Ilagay na natin sa taas. Plus, okay, the ln nung ratio ng radii 3 over radii 2 divided by 2 pi K2. Okay? That is very basic. And so on. Okay? Kung gaano man kakapal yung pipe mo. Okay? Yan, papasok yan. What about, sir? Di ba meron tayong fluid transfer? Pwede rin naman ulit. Pwede rin naman ulit. Okay? Oh. Di ba ang general formula natin for that, kapag meron tayong surface conductances, di ba Q is U, A, delta T. Di ba? Ganyan yung formula natin. Q, A, delta T. Oh, coming again from the general formula, we transfer delta T over the total resistance. And again, for steady state heat transfer, the heat total is equal to the individual heats between sections or it is constant. O, nagkaroon tayo ng surface film conductance. O, the inner one and then the outer one. O, meron na tayo nitong mga formula. O, ilan heat natin dyan? Okay, individual heats. You have inner, side number 1, side number 2, and outer. So, 4 na heats. 1, 2, 3, and 4. Paano natin sila pagsasamahin? Oh, going here. So, going from inner to outside, the total heat now will be equal to, anong pinag-usapan natin? Inner and outer. So, Ti minus To. Oh, unahin mo yung alam mo. Okay? Unahin mo yung alam mo. 1 over Hi multiplied to the area nung inside. But, ano bang area ang pinag-uusapan natin dyan sa inside and outside? Simple, ito lang. 2 pi RL. O, basic yan. Okay? Where A1 or A inside, 2 pi RL. 2 pi RL. Bakit po naging ganun, sir? Okay, tignan nyo ito. Diba meron tayong, going here, tuloy natin yan. Diba inner and outer, ano bang area nito? Kapag binuyang-yang mo ulit, okay, hinati mo dito. Okay, naging ano naman siya, strip. Okay. Naging strip na naman siya. Diba, nung kinat mo ito, na ano siya, na-expose, meron kang length dyan. So, this is now the circumference nitong circle nito, o di 2 pi r inside, multiplied to L. Ano po ba ang rectangle? Area ng rectangle, ano? Diba length times width? O, simple, ganun yung area niya. So, the area ni AI is 2 pi RL. Plus, yung sa pipes naman, transfer sa pipes, ln ni R2 over R1 divided by 2 pi K 1 L plus, wag nyo na iakyat yung L, malilito na kayo dyan. Okay, may fluid to fluid na yan. Loan ng R2 over, hindi na pala R2 yan, R3 na yan, over R1 divided by 2 pi K 2 L plus, yung outer naman, 1 over HO, area O. Okay, yung area O, outer, yun pa rin naman, 2 pi R3 L1. Kasi yun yung raday niya. Okay? Gets? I think what better way for us to understand it is to put it into different problems. So, these are the problems. I have here 3 for us to answer. Okay? So, you just have to take a look. I will answer it right now. So, let us go with problem number 1. Okay. Problem goes like this. Pwede ko pa i-simplify yung dulo niyan, ha? Later ko na lang gagawin. Pwede yun pala, simplify ko na lang muna. So, dito, i-generalize natin. I-shortcut natin. When we are talking about pipes, tayo ha. When we are talking about conduction through pipes, pipe lang ha, pipes. Simply, okay? Yung heat transfer niya will be equal to, ayun, no? Generalize natin, ha? 2 pi L K delta T over loan ng R2 over R1. That is the general formula for pipes only. Now, kapag sinabing composite pipes, the total heat is, di ba same naman to? Same naman yan. Pwede natin i-factor out. Okay? So, 2 pi L over 2 pi L multiplied to the change in temperature. Okay? Divided by yung natural logarithm nung unang section, R2 over R1 over K sub 1 plus natural logarithm ni R3 over R2 over K2. Pinactor out ko lang naman yung same. Pag naman, composite pipes, with fluid to fluid transfer. Papakita ko sa inyo yung proper way of solving this, ha? Para hindi kayo nalilito. So, the total heat, okay, is equal to, pwede mo naman dito kasi i-factor out. Tignan mo ito, ha? Expand ko to, ha? Para maintindihan natin. So, QT is TI minus TO. Parenthesis. Divided by 1 over HI. Yung area niya, 2 pi R1 L. Okay? Plus the loan nung R2 over R1. Haba na ito 2 pi K sub 1 L. Plus yung pangalawa, the loan nung R3 over R2 divided by 2 pi K2 L plus 1 over HO multiplied to 2 pi. Ano yung pinaka-outer radius niyan? That is the 3. Okay, the third radius, R3, L. O, tignan nyo dito ano yung common sa kanila. Di ba ang common dyan is yung 2 pi L, 2 pi L, 2 pi L, 2 pi L. So, pwede natin silang iakyat dito sa taas. Then we can simplify the whole equation. So, that is Q equal to 2 pi L Ti minus To divided by 1 over, ilabas na natin R1HI plus ln ng R2 over R1 divided by K1 plus ln ng R3 over R2 over K2 plus 1 over HO tapos R3. Very basic kapag composite pipes with fluid-to-fluid transfer. Magkakamali ka pa po dyan? Hindi na po. Okay? Let us go with this problem. So, a pipe with an outside diameter of 2.5 inches is insulated with a 2-inch layer of asbestos where the thermal conductivity is 0.396 BTU inches per hour feet squared degree Fahrenheit. Ako, nakakalito. English unit. Ang haba ng conversion. Followed by a layer of cork which is 1.5 inch thick. Which is 1.5 inch thick. And that is 0.3 BTU inch per hour feet squared degree Fahrenheit. If the temperature of the outer surface of the cork and pipe is 90 degrees Fahrenheit, the cork and the pipe, okay, and 290 degrees Fahrenheit, ito yung sa cork, ito yung sa pipe. Respectively, calculate the heat loss per 100 feet. Per 100 feet, ibig sabihin, this is the length of the insulated pipe. Okay. Let us, alamin natin to. Now, ano sinabi dyan? 2-inch layer of asbestos. Ibig sabihin, this is asbestos with the thickness, layer nga Pag sinabing layer, that is thickness. 2 inches. Now, sinabi dito that the pipe with an outside diameter. Ibig sabihin, from here up to here, yung piping mo is 2.5 inches. Ibig sabihin, kalahati ng 2.5 inches will be R. So, R1 mo is 1.25 inch. Okay. Okay na yun, ha? And then, it is followed by a layer na naman. May layer ka na naman daw dyan ng cork. That is cork. Ang layer niya is 1.5 inch thick. Very basic. Now, if the temperature of the outer surface of the cork, ibig sabihin, at this point, meron kang 90 degrees Fahrenheit. Okay? And the pipe, ibig sabihin, in here, it is measured at 290 degrees Fahrenheit. Okay? What will be, again, class, what will be the heat lost per 100 feet of the insulated pipe? So, the length is 100 feet. Okay? Meron tayong heat transfer na nangyari dyan. Okay? Q. Dito asbestos, asbestos. Ayan, asbestos. Now, let us elaborate. Paano natin i-measure yan? Okay. Ako, ang pinakagusto kong ginagawa dito pag nagsosolve ako, ang ginagawa ko dyan is, hinihimay-himay ko. Okay. Saan ko kukunin yung R1? Siyempre, nasa loob. R1 is for pipe only. The size of the pipe only. Yung R2, saan ko kukunin yan? O, di ba yung R2 is equal to R1 plus the thickness ng cork? O, yung R3, o, di ba yun yung R1 plus the thickness of the cork plus yung thickness ng asbestos? Ay, baliktad pala. Nauna pala asbestos. Asbestos. As na lang, asbestos. ASB. Ito is ASB. This is cork. Okay? Oh. Or this is equal to R2 plus thickness ng cork. Oh, very basic. Diba? Makukuha mo na si R1. R1 is, the value is 1.25 inch. R2 is 1.25 inch plus 2 inches. Oh, that is equal to 3.25. Oh, pag R2, R3, 3.25 plus 1.5. Oh, problema ba yan? Di 4.75 inch. Oh, di meron na tayo mga values for the radius. Now, as you can see, lagi nating sasabihin that it is steady state. Okay? When it is steady state, ibig sabihin yung pipe, yung total heat transfer niya is equal to the overall heat transfer ng bawat isa. So, Q ng asbestos equal to Q ng cork. Punta tayo sa equation. Di ba ang Q, dalawang pipe lang naman ang pinag-uusapan natin dito, dalawang composite. So, this is Q, 2 pi L, tapos multiply to T1 minus T3 over yung natural logarithm of R2 over R1, yung K1 plus ln ng R3 over R2 over K2. Anong hinahanap natin dito? Heat loss per 100 feet of insulated pipe. What is the heat loss? Okay, lagay natin dito. Magko-convert pa ba tayo? Nasa English na lahat yan. Okay na po. So, Q is equal to 2 pi. Ilang yan? Feet? 100 feet. Multiply to TI, 290 minus 90. Degrees Fahrenheit. Change in temperature. The natural logarithm. Huwag natin lagay unit kasi parehas lang naman yan. 3.25 over 1.25. Okay? Divided by K1. Anong unit nun? K1 is ng asbestos 0.396 BTU inch. May ko dito. 0.396 BTU inch per hour feet squared degree Fahrenheit plus ln nung R3. Ano ba yung R3 mo dyan? 4.75 divide by 3.75. Hindi, 3.25 yan. 3.25. Yan. Divided by 0.30 BTU inch per hour. Feet squared degree Fahrenheit. Sir, ang hirap ng unit. Hindi ko kaya i-solve. Well, actually, kaya mo i-solve yan. Anong conversion factor mo dyan? Sige nga, anong conversion factor mo dyan, my friend? Simple lang. Diba? Multiply mo na lang buo yan ng 1 feet para maging square yung feet per 12 inch. Makakancel mo yung inch dito. Tapos yung feet, makakancel mo rin kasi feet squared. Then we cancel all the same units. Okay? Anong kailangan niya? The heat lost. Okay. Anong unit yon ang hinahanap? BTU per hour kapag English. Kailangan matira BTU per hour. O, i-cancel natin yung mga same units. Feet, yung inch. Sir, paano na-cancel yan? Akyat mo ito dito, may reciprocal. Okay? Yung feet squared, cancel yan kasi may feet squared ka dito sa taas. Yung feet squared, cancel dito. Yung degree Fahrenheit, iakyat mo dito sa taas na ito. O makakancel yung degree Fahrenheit. Yung degree Fahrenheit and degree Fahrenheit. So what did, natira? Ano yung natira? BTU per hour. Akyat mo sa taas yan. Okay? Ano lang po kadali. We can solve for the value. 2 pi times 100. O ito, pwede na itong mental math. So, 290 minus 90, that is 200. Divide by the loan ng 3.25. Ito, kasya pa, pero yung mamaya hindi na kasya yun. Ang haba nun. 1.25 divided by 0.396. Okay? Plus the natural logarithm nung 4.75 over 3.25 tapos 0.3. The answer will be, sir, meron tayong ano pa dyan. Hindi pa yan BTU per hour. Kasi nga, hindi pa din-divide ng 12. So, divide it by 12. So, the power or the heat loss per 100 feet length is simply yung value Q is equal to 2847.291 BTU per hour. Very basic. Okay? That is for problem number 1. Ganun lang po kadali yun. So after, mamaya turo ko sa inyo conversion factor nitong unit na to. Okay? Para maging lang siya, watt per meter degree Kelvin. So, number 2. Okay? Lapit natin para mas maganda. Kitang-kita. Yan. So, calculate the heat loss per linear foot. Per linear foot, from a 10-inch nominal pipe, okay? Outside diameter is 10.75. Sir, ano yung nominal? Wag mong pansinin yung nominal. Ha? Ang papansinin mo dyan yung sinasabing outside. Yung 10-inch kasi, yung 10-inch is the size niya given. Pero, merong thickness yan. Okay? Yung thickness niya is half nung kanyang extra dun sa 10.75. Okay? The nominal size. Or the, tawag dito, product size yan eh. Pero hindi yan fitting. Or, yan yung tawag dito, parang allowance yan for it to cut. Okay? Nominal or normal size. Okay? For sizing, meron chart yan. So, adjusted size or the allowances. Yun yung tama. Covered with a composite pipe insulation consisting of 1.5 inches of insulation. Insulation 1. And then placed next to the pipe and 2 inches of insulation number 2 placed upon insulation 1. So, this is insulation 1. Okay, nandito. This is 1. This is 2. Okay. Assume that the inner and outer surface temperature of the composite insulation, inner muna is 700 degrees Fahrenheit. Yun nandito. 700. Inner. And then outer. Dito. That is 100 degrees Fahrenheit. Respectively. And that the thermal conductivity of material 1 is 0.05 BTU per hour feet degree Fahrenheit. And then yung isa is 0.39 BTU hour feet per degree Fahrenheit. So, magulo ba? Well, actually, ganito lang ang pag-solve sa kanya. First, we have to determine yung R1. Saan yung R1 dyan? Ano sinabi? Nominal ba gagamitin mo? Don't ever use yung nominal size. Ang gagamitin mo is the outside diameter. Okay? Of the piping. So, the outside diameter of the piping is 10.75. Pero, diameter ang sinasabi dyan ha? O, i-divide mo ng 2. Magiging inches. Yung R2, di ba yan is R1 plus the thickness nung insulation 1? Ano ba yung R1 natin dyan? 10.75 divide by 2. That is 5.375 inches. Yan yung R1. How about R2? That is R1 plus T1. 0.375. Plus, ano yung binigay na value dyan? 1.5. So, it is equal to 6.875 inch. Yung R3, simply is R2 plus T insulation 2. Oh, that is 6.875 plus 2 inch. The 8.875. Meron na tayong radius. So, wala naman sinabi dyan na surface film conductance. Ang hinahanap lang is the heat loss per linear foot. Okay? Heat loss per linear foot. Simply, meron tayong formula. Ilagay natin dito yung formula natin. Q is equal to 2 pi L multiplied to T1 plus tuloy. Sorry. T1 minus T3 all over the natural log ng mga raday as K1 plus natural log ng isa pang raday K2. Okay? So, anong hinahanap natin dyan? Yung per unit length. Okay? Per linear foot o di Q over L na to equal to 2 pi. Ano ba yung temperature dyan? Inner and outer, 700 and 100 degrees Fahrenheit. O, natural logarithm, R2. That is 6.875. Tapos, yung 5.375. And then, yung thermal conductivity nung item 1, that is 0.05. BTU per hour, degree Fahrenheit, tapos feet. Tapos, dito na yung 8.875 over 6.875. Divided by, ano yung isa? 0.039 over hour, degree Fahrenheit, feet. Anong kinukuha natin dito? Per feet length. Okay, per feet length. Ano maka-cancel natin dito? Tignan nyo kung ano maka-cancel. So, yung degree Fahrenheit, degree Fahrenheit, degree Fahrenheit, BTU per hour. Okay? BTU per hour is the unit of heat loss. And then per feet length. So, natira yung dalawa. Okay? So, we can now solve for the value. So, 2 pi times, this is calculable naman. 600 na lang. Calculable mentally. And then, loan nung 6.875 divide by 5.375 divide by 0.05 plus the natural logarithm ng 8.875 divided by 6.875 and then divided by 0.039. The answer will be 3.28. Okay? Yun ang magiging sagot natin. Very basic naman yan. Q over L is equal to 3.28 tuloy. 328.675 BTU per hour feet. So that is the heat loss per feet length. Okay. Very basic. How about problem number 3? I bet this one is quite long. So please bear with me. Okay, masosolve natin yan. So let us first understand the problem. A pipe with an outside temperature of 150 degrees Celsius and an outside diameter of 1.4 cm is insulated with a layer of asbestos. So nasaan yung asbestos dyan? Ito nasa loob. Asbestos. Okay? Where yung K niya is given here. Followed by a layer of cork. So ito yung cork. Nasa loob. Which is 0.5 cm thick. And if the temperature of the outer surface of the cork is, sandali lang ha. Kulang ng isa. Wait. Let me check. Ayun, pipe lang pala yung loob. Asbestos and cork lang. So this is the asbestos. May thickness talaga yung pipe. Kinonsider ba dyan? Hindi. This is asbestos. This is cork. Yan. So ibinigay na dito yung kanya mga temperatures. Anong kulang po dyan? Steel? Meron pa binigay dyan na steel? Actually, wala. So, eliminate natin itong loob. Kulang nga yung given na yan. So, ito binigay niya dito. If the temperature of the outer surface of the cork is 32 degrees Celsius and the heat loss per 30 meters of insulated pipe is 900 watts, find the maximum thickness of asbestos in cm. Ang hinahanap natin dyan is the thickness of the asbestos. Okay. Di ba nakakalito? Paano tayo? Palipat-lipat tayo ng units. Bibigyan ko na kayo ng key conversion factor. So, the key conversion factor here, take note of this magagamit nito. Very useful to. Is 1 watt per meter degree Kelvin is equal to 0.578 BTU per hour feet degree Fahrenheit. Okay? Ito yung key conversion natin. Don't you ever forget this one. Malaking bagay ito. Okay? So, we can now convert itong mga resistances na to. Okay? Yung K ng asbestos, that is 0.396 BTU per BTU inch. Yan, BTU inch. BTU inch hour tapos feet squared degree Kelvin. Okay, convert ko to. Okay? So, 1 watt per meter degree Kelvin is equal to 0.578 BTU per hour feet degree Fahrenheit. Now, kailangan eliminate natin dito yung inch, okay? May inch dito sa taas, di ba? Kailangan ma-eliminate natin yung isa pang feet. So, there are 1 feet in every 12 inches. So, we can cancel all the same values, same units. So, 1 feet, yung feet dito, yung feet dito. Okay? Para maging watt per meter degree Kelvin. So, BTU, BTU, hour, and then degrees Fahrenheit. So, mali lang ako dito ng lagay. So, degree Fahrenheit. Yan. Cancel na rin yan. We can now arrive with an answer of, hindi pa yan ha, mahaba talaga itong problem na to. So, 0.396. Tapos, 0.396. 0.578 times 12. The answer is, round up mo na. KA. Is equal to 0.0571 watt per meter degree Kelvin. That is for KA. How about yung sa quark? Ano yung value ng quark na binigay dyan? That is 0.30. 0.30. Multiply mo na lang to. Yung unit niyan, magiging ganito na rin. Hindi ko na pa ipakita yung yung unit cancellation para hindi tumagal. So, 0.30 divide mo na lang ng 0.578 times 12. Ganito parati yung process niyan para may convert mo. Multiply mo na lang ng unit. Watt per meter degree Kelvin. Yan na kagad yun. So, the answer is 0.3 divide by, palitan ko na lang yun nandito pala. Yung inuna natin. 0.3 divided by 0.578 times 12. The answer is 0.0432 or 433 watt per meter degree Kelvin. Yan ang mga resistances mo. Okay? And then, hanapin mo na kagad yung mga radius. Okay, lagyan natin linya dyan para hindi nakakalito. Raday 1. Ano yung raday 1 na binigay mo dyan? R1. That is 1.4 cm or in millimeters, 14 millimeters. So, hindi raday yan. That is the diameter. 14 millimeters divided by 2 o 7 mm. R2. That is, in millimeters yung 7 mm plus X. Ano ba hinahanap mo dyan? Yung thickness of the asbestos in cm. Okay? Asbestos is the thickness. Okay? Yung X is thickness ng asbestos. Thickness of asbestos. Ayan. So, X. R3. Yung R3 is 7 plus X plus 5. O, simply, that is 12 plus X mm. Yan yung R3. Ito, hindi natin alam. Alam natin. Okay? Dito tayo, babalik mamaya. Okay? This is question. So, we can say that the total heat resistance is equal throughout the system by steady state flow. So, Q nung sa asbestos is equal to the Q ng quark. So, individual ang gagawin natin. We are given a total, okay, yun sa inside, okay, sa pipe, that is Q is 900 watts. Okay? And it is given by the formula T1 minus T2, yung inner. Yan binigay dito. T1 tsaka 2. Going here, okay? 900 watts yung binigay sa'yo. So, 900 watts, T2 multiplied to 2 pi L over lone nung R1 or R2 over R1 divided by K. Yung asbestos yan, ha? And then, dun sa Q, equal pa rin sa 900 watts. Kasi equal nga talaga sila dahil constant nga. So, T2 minus T3, 2 pi L over lone nung R3 over R2. Kung i-simplify mo yung RT and R2, marami yung X. Okay? Over K ng cork. Asbestos. Yan. Kung i-simplify mo. Pero mas maganda kasi, kunin natin yung pinaka-value ni R2. Okay? Napakahaba ng problem na yan. Okay? Meron tayong missing link dyan. Kailangan i-solve mo siya isa-isa. Dito may masosolve ako R2, 7x, ln. Okay. Dito muna ako mag-solve. Okay? May temperature difference naman dyan. So, T2, T1. Yung sa 1, 150 degrees Celsius. Okay? Outside. And then yung inside, nasaan? Binigay ba inside dyan? So, from 2 to 3, that is may x eh. Okay? Hindi natin alam. Ika-calculate natin. So, let us take a break here and then let us continue it next week. Okay? Next meeting. So, I will put you on hold with this kasi ito, sinolve ko na yan. Okay? Gagawin natin tong to be continued. To be continued. So, I think that will be all for today.